Okay, let's continue on with 10.8 division with polynomials. I wrote this one out using the long division template, and we'll get started on it, and we'll see how many of these we can get through in about a 5 or 6 minute video. So when you take a look at this, like the previous one, what you'd like to do is kind of find something that would go right up here. So when we multiply it by p squared, we get exactly p to the third. Okay, so what I'm going to put up here is going to be p. Okay, then when I take p times p squared, I'll get p to the third. But I have to distribute this p to this entire trinomial here and then write my result down here. So I'm going to do that. I get p times p squared, p to the third. P times negative 5p is negative 5p squared, and then p times 5 is 5p. Okay, so now if you remember the division algorithm from earlier, we can draw a line here, and then we're going to need to subtract this polynomial from the above terms or polynomial. So to take care of the subtraction, what I can do is I can change all these signs. That makes them helps us take care of the subtraction. So here we can put these terms together, and they're already lined up in columns. Okay, so we have negative 4p squared, and then 20p, and then what I'm going to do is bring down this constant term, or this last term here. And then I'm going to go up to the top and I'm going to repeat the process that I just did. I generally wouldn't put this box, but just when I'm starting to learn how or teach how to do this, I like to have the box there. And you think about, what could I take times p squared to get negative 4p? Okay, so I'm going to take a negative 4. Okay, so I have negative 4 times p squared is negative 4p squared. Negative 4 times negative 5 is positive 20p. And then negative 4 times 5 is negative 20. Now you might see what's going to happen here. We have exact match here, but if we were just kind of in the groove and we drew our line and changed the signs to help with subtraction here, what happens is everything here cancels out. You see that they're opposites of each other, so we get 0, which is our remainder. So remember how we write our answer now. The answer of a division problem is up here. Okay, so we'll write our answer as the polynomial p minus 4. Okay, let's look at another one here, and we'll finish off these 3 in this video. The video might get a little long, but that's all right. We can you can fast forward it. So I'm gonna put x plus 1, my denominator, into x to the third plus 3x squared minus 2x minus 4. And I'm going to come up here and then think, okay, what do I put up top here? Let's see, I'll put an x squared. I won't use the boxes this time, but I'll use the different colors. So I get x to the third. X squared times 1 is positive x squared. I like to put my signs in there. I'm going to draw my line, change my signs, and I get 2x squared here minus 2x minus 4. You wouldn't have to necessarily bring that 4 down at this time, but it's not going to hurt anything. And then I'm going to think, okay, what times x gives me 2x squared? Well, positive 2x. 2x times x, 2x squared. Then I have 2x times 1 will give me positive 2x. Being careful with my signs here. I'm going to draw a line, change my signs. Don't forget to change both the signs here. And I get minus 4x minus 4, and bring that 4 down. So I come back up to the top, and I need a negative 4, because negative 4 times x will give me negative 4x. And the negative 4 times 1 is negative 4. And what we see again here is you get a perfect match. You probably know from the previous problem what's going to happen, but we get 0 for a remainder here. So our answer to this problem is right up here, and that's what we would type into the Hawk system or write on our paper. Okay. And then looking at this last one here, G, what we have, I put this one on here because I wanted to remind you, and you probably won't get one like this, that you can factor a negative out of this, or that's one way you could do this, but you want to put this in the correct order. So you think about it as 6x squared minus 3x plus 2 over negative 2x minus 1. Okay, and we can work with this. You know, I don't think you'll get one with this negative sign in the front here and of this binomial, but we could still work with it in case you did. We'd write negative 2x minus 1, and we divide that into 6x squared minus 3x plus 2. So our first thing we're going to need is a negative 3. That'll make the positive 6, and then x. So that'll make 6x squared here. Then negative 3x times 1 is positive 3x. I'll draw my line, change the signs. What I get is negative 6x here plus 2. You want to be careful with this column. And then I'm going to think, okay, what times negative 2 gives me negative 6? Let's see, that is a positive 3. 3 times negative 2 is negative 6x, and then 3 times negative 1 is negative 3. So I'll draw the line, change my signs, and what happens here is this time I get a remainder of 5. So how do we handle our remainder? Remember, we take our remainder and we write it over what we were dividing by. Okay, so I would take this, bring it way up top here. I put a plus sign because that's a positive 5, and then I have 5 over negative 2x minus 1. Okay, now just to show you, factoring a negative, what might have happened here with this final answer is you might have factored a negative out of this denominator here. And so if you factor a negative out of the denominator, we would end up with negative 3x plus 3. And then we could put the plus sign so for our remainder, and we'd have a negative 5 over 2x plus 1. Okay, it's just a different form you might see the answer in. Okay, so there's different ways to do this one. Someone might have factored the negative out of the beginning here and moved it to the numerator. This one's a little more complicated because of the negative sign. So, well, I hope that helps. It's a little long video, but you can skip through it and look at those division problems. Thanks.